and welcome to another advent of code on SerenityOS using the jakt language. My mouse is finally going. So I think if I refresh this, maybe we should get that. Maybe I need to change this, add a few more letters to bust the cache as they call it. And we can look at day 8. And I suppose at the same time we can start a new day, and that input looks typable in, I guess. What do we have? 30373 and what is our output? 21. Part 1, 21. And we can just open up the text editor. Actually, I wonder if Hack Studio, yeah, we might do Hack Studio on day 8.jakt and just see how that goes. Right, we can't do that, but can we open up all of them? Right, so we can open up all of them and we can go to day 8, wasn't it? Yeah, try out this editor, see if it's nice or anything. Right, so if we take off always on top there, and we can start running. Learn to spell. A bit headachy this morning, but should go alright. Oh, we potentially can just do like all the git stuff in here, and I wonder if right, yeah, we can potentially work out how to get a console going, and maybe like build software build. Right, we don't have a make file. We could probably make a make file, and we don't have a run. Let's do that. Make file, and what do we need? We needed a target for run and no target, so maybe just run and we can call it all. How do we do this? It's like run was what we wanted. Run, and it depends on like start.jakt, I guess, and test.sh. What other files might we change that we care about? Maybe helpers.jakt should get included. That's that, and then I think it magically added that tab, because you need a tab in make files, not spaces. It has to be a tab. And what is the command we want to do? We want to just do test.sh. And like maybe that'll work. I don't know. Not sure how useful this is, but Control R. Right, so let's just not depend on anything, because otherwise things won't know. It should. Yeah, I would have thought it would just know. Right, now it's yeah, it seems like we're not in the right working directory for that. Oh no, we just haven't. Unsure what has happened there. Right, that did it. Cool. So now runs our everything, which like isn't really the best, because what we really want is only to do day 8. We're recompiling day 7 for some reason, not sure why. And yeah, so overall we should have failed on that. It's kind of cool that it's like integrated into the editor. So just day 8. So what I might do is just do this in 8 example. It's weird that we get that stat error, and so if we run this now, like, yeah, maybe I can't like have that. Cool, and that kind of does it. And like, yeah, I would like that bigger, but I guess we can run it and just scroll up. Anyway, so what are we doing for day 8? So we're on a march. The elves are on a march, as they are, and they come across a bunch of trees that are planted in a grid, because in a previous advent of code, I guess, weirdly it hasn't linked to that previous one. They planted a bunch of trees, and they want to build a tree house, and to do that they need to work out whether they can hide the tree house and so blah. So we have a quadcopter flying over to work out the heights of all the trees, I assume. Yeah, so each tree is the value of its height. So 0 is the smallest, and 9, if there's 9, yep, there is the tallest. So now we need to work out if it's visible between it and a grid. Only trees in the same column. Right, so basically we would look at, say, this 5, and we would look that way, and we'd see it would be visible from this left direction, and if we go up it would also be visible there. This 5 would not be visible from this direction, because that 5 would be blocking it, I guess. Yeah, they have to be shorter, so if they're the same height, I would take that as it will block that tree. So that 5 is not visible from that direction, but it is from that. And this one, yeah, most definitely can't be seen from all directions, so that is hidden. Keep an eye on time. Right, so, and everything around the edge is visible just by definition, I guess. And so we have to check that. So that one is visible and cool, and right, so I did those top 3 and was right, so I'm going to assume that. And so we want to work out how many visible trees there are. Cool, I reckon that's fine. So to pass the input, now one problem with this is that font is tiny. People will not be able to see that, I guess. Can't remember what font I was using for the other one. I'll find one that has a big one like this. Oh, it's like a serif. How's it look? Yeah, I'll take it. I do. Yeah, fonts are interesting. I might try and import a font to Serenity if I feel like it. I don't know. We'll see how I go. Right, so to read the input, we kind of need to store a bunch of things. These are just going to be 0 to 9. So what I'm going to do is just loop over the bytes of each string. So we're going to have a map, and it is going to be a double array of U8, and we can just have it empty for now. And when we would have a we'll call it row, and that can just be that, and it's going to be a type of just a single array of U8. That sounds good. And then we're going to go for byte. It just takes an index, so we'll go with that 0 dot dot line dot length, and row we'll see if it complains. And then afterwards we just need to go map.push row, and I'll get rid of that, and we'll go print line. Yeah, it's kind of interesting, this point, like it's kind of overlapping, like it's cutting the bottom off sometimes but not all the times. Yeah, like if you're on the row it's highlighting that line and the font cliff is like slightly up, so it kind of hides stuff, but I think that's right. It only really affects the row above, and I find like this quite readable, so I think I'll stick with it. So we'll see what our map looks like after reading it, and yeah, we can go make run, and it will compile and see how that goes. Right, so we've yeah, so here is what our map looks like. Now this is in ASCII characters. So what we actually want to do is minus the character 0 as being U8. I think that's what we'll want. And if we recompile that, then the map should be 0 to 9 range, which will make it easier to reason with. It's really just for me though, because like, if we used this map with the higher numbers, we can still tell whether something is visible or not visible, depending on that. So we just want to count how many visible things there are. So visible, I'll just make a function is visible. And we'll take the map, which is going to be a U8. What I like about this is, like, by default it will not be mutable, so I can like safely pass map to it and it'll just do it. And then I guess we can have X, which can be a U size maybe, and a Y, which will also be a U size, and we can return a bool. See, this is interesting because it's like highlighted that we can't see the underscore that is in between these, but if we go here we can't see it again. So I don't think it's like a biggie, but yeah, I just noticed. And we kind of need the big font in case like people are reading on other screens. I had a look, and the smaller font, like this stuff here, like it's quite hard to read on a big screen if you're kind of watching this video afterwards. Right, so if we're visible, what we want to do is see if trees around it. So we can get our current size, and that can be map X. Oh, so each row, yeah. So we'll have Y to start with, and then X. Yeah, that makes sense. And we'll have it 0 based, and I'll just know that it's 0 based. Right, and then we want to kind of go for, I wonder if we can do something like that. And 0 dot dot. Actually, we'll yeah, so X and 0 dot dot map Y dot length, and if X equals X, we will, I wonder if we need the curly braces there, so I'll just see if that kind of works. Right, that like breaks things. Whoa. So what is it complaining about? Yeah, so we do definitely need a brace there, and I think we also need a throws. I also saw in the output. I kind of want to go to end of line. Right, so if we do that, and I kind of like already that it's showing me the diff in the getter bar, like what I've changed on the file, because it knows about Git. right, so we need to maybe just call these I64s. Yeah, I'm happy with that. But then like it might not like it in its size for a array. Size for an array still thinks that's usize. Alright, let's try usize it again then, just for the x, and that's where the complaint before. Must have been because of some other error. Right, and then we just haven't returned anything. So if we're going to go through and basically see if it's not visible, if it is visible because something is, well, yeah, as soon as it's hidden, we will return false. So at the end, we will want to just return true. So they'll fix one of the errors, and then we can do the same in size. And if y equals y, then we can continue. Alright, so that does that, and that should compile, but not actually do anything useful just yet. We don't even call this is visible yet. So every time we look, we want to compare the size with what is in that. So if and if it is hidden, yeah, if it's hidden, we want to return false. So if something, we want to return false, and that something is going to be if our size is less than, less than, not less than, equal, and it's less than yx. Yeah, and a similar check here if size is less than map. I've done that, but I knew what thing it was, so that's alright. Return false. Might actually keep it, I don't know. Oh no, it's like completely full screen. I don't know. Right, so I think that is visible is fine. I might kind of make it a bit bigger if we can. Don't want that. Yeah, something like that, just so I can fit a bit more code in. And maybe this can go slightly here. Cool. And then this can just go over there. Right, so now we want to basically iterate the map. Mute, I don't know, num, and it can be, it can probably just be 0 and it can work it out. And so here we want to loop over x and y, so we'll do y first, 0 in map.size, and then for x in 0.map, y.size, scroll down a bit more, and then if is visible of our map and our x and our y, then we will num plus and here instead of printing the map we can do something like part 1, and that can be num, and this might just work. Real hopeful, but it is how it is. I wonder what part 2 will be like if this is right. Right, so I got 5 and there were 21, so it was not quite right. So I guess some things here were not right. So I might do some debugging. Not visible at obscured by and right, so this will be X and Y, and this will be X. I didn't want that. And Y. And this will be size, and this will be map of Y and X. I think that is alright. Right, so we do have double copy, triple click on it, and we can do the same here, except move that to there, and that, and run that, and we should get some debugging output as well as the part 1.5, which it shouldn't be 5, not sure why it was 5. Right, so 0, 0, what do we have? 3. Yeah, so if we get to an edge, we need to say it is visible. Because yeah, this 0, 0, it's already at the edge. So I think we need to change how we do this. Yeah. Because as soon as we get to one edge, we know that it is visible. So we don't need to check like the other edges if that is the case. So I think what we want to do is return false as our case when we don't get it, and if we find something that is bigger, we kind of want to loop from X. Right, so I'll do this again. Yeah, I think I recall this from another problem that we couldn't have a for loop that kind of went backwards. Yeah, I think maybe I'll have a new rep, and that can be true. And we'll have to do something like that. And if so we'll never hit that if that, and if we this means it should be false. And I guess in that case we can also break, and if not ret, actually no, if ret, we can return ret and do that. Otherwise it's still true. Well, no, then we want to set it back to true again, and then do the loop from x plus 1 to x plus 1. Now I think I'll probably need to wrap that. I'm just going to do that just because who knows. And this will go to map y.size y off by 1, size, and do the same there. And I guess we can do that and return ret instead of false. And then we kind of want to do that and also have this. Right, so at that point there we can do that. Right, so x and that. So now we're doing y. That would be about if I forget that. Not g. That's not by 1. Sorry. Right. So then we want to do y again, and it's going to be from y, and it's just going to be just the map, and we're going to do that and run that, and I think that will probably do the trick. Hopefully. You just never know. That crashed. Right, so we might get some output anyway. So if we go to day 8, right, overflow. Yeah, so we did a y minus 1. I think we just want to go to y because it never really goes to it. Like here, the upper bound is the size. So that probably shouldn't overflow. Well, that's really an underflow. Right, now we got 23. So I guess we overdid it. I guess. So print line. X, Y, obscured by, I'll just do that, X, Y, and X, Y, and copy that in a few places, and here we want to do the same, but instead of that one, we want that one, and do that there. Right, so one of these is wrong. So the edges should all be, so if it's got a 0 in it, yep, so if this side has a 0 in it, it should be visible. No, that's not quite right. Anyway, I think I actually have to stop here because I've got something else coming up. So I'll come back to this and work out how I'm going, because yeah, it wasn't as straightforward as I thought, and a bit headachy, and that's probably why. So I'll see you next time. It might be a completely new video, who knows. Hello and welcome back to the same video, maybe? I think I'll just join them up. So just before I was going through working out what was wrong with my is visible function, I made a couple of things off screen. So I think where we got up to was, yeah, we did the subtraction and then we were getting the wrong answer. So we were getting 2 extra from what it was. So I started putting in some comments on what trees were obscuring. Didn't realise that wasn't actually giving enough information, so I started saying what it was obscuring and whether it was visible and which direction it was. And then I so that still had the wrong answer, and then I made another change. Yeah, this change I added a check at the top, basically to see if it is on the edge. If it is, then return true. And so basically I got less output there than I could see what was wrong. So if we look at this, it says 1, 1 is visible from the left, that one there, and it says 2, 1, this 5 is also visible from the left. At which point I realised I wasn't testing less than or equal to, so I went through and added these equal signs in all the right places, and then the next run doesn't have the diff showing the part 1 being wrong. So what I can do is get rid of all these print statements, and that one, and this one, and that one, and this one, and this one. We can just delete that whole block. And so now if we run it, it should just be fine. It should run fine, give me the right answer of 21. So this will just say it passes because it doesn't diff. It says, right, does that occasionally. And what we can do here is, now that it's like not just spitting out the wrong answer all the time, we can do that, and not spitting out like the input file, which could be a bit messy. We can submit that 1690, and I'm fairly confident that it will be correct. And yep, got a gold star, so we can go to part 2. So if we output the 8.output, we can put that there, and also do output the 8.example, and we're looking at part 2 now, and our scenic store, that's what we're getting, is 8, was it? Yeah, 8. So part 2 is going to be 8. So we need to work out what the scenic score is, and we can probably run that, and it should fail on the example input. It still passes on the actual input, but as soon as we start writing, I want that. As soon as we start writing part 2 output, it will fail. Alright, so part 2. They are happy with the amount of tree cover available, so they need to work out where the best spot is. So they want to be able to see lots of trees. So we need to work out the viewing distance. Look up, down, left and right from that tree. Stop if you reach an edge or at the first tree that is the same height or taller than the tree under consideration. Gosh, alright. If a tree is right on the edge, at least one of its viewing distances will be 0 because it's like right at the edge. Don't care about distant trees taller than those. Right, so the tree house has some eaves, the things on houses overhanging the roof. Right, so they can't see above the tree house, so they don't care about things that are taller than. Right, it's kind of weird that they say look up, down, left, right, because they're kind of assuming that we're looking up, down, left, right in this 2D map, but really from the tree we're looking like north, south, east, west, I guess, because up is up the tree and down is down to the ground, but I think that is what it means. Right, so we're considering this 5, looking up, north we'll call it, looking north, view is not blocked, it can only see one tree. It can see one tree, right, so we can see one tree. Looking left, it's blocked by that 5, so it can only see one tree. Right, so we just need to count how many trees each thing can see. And looking right, it's not blocked, so we can see 1 and 2. And looking down or south, we can see 2, I guess, because it's blocked by this 5 here. And then to get the scenic score, we multiply each of those directions and get an answer. Right, so and then consider this one, we get another one, and that one has a scenic score of 8, and we need to get the highest scenic score, which I'm assuming is that 8. Right, so I guess we will have like a mute of max, and that can be 0 to start with, and yeah, so I guess we will have a loop that goes over all of the coordinates, and then we want to let score equals scenic score using our map and our x and our y, and that function will define, and if score is greater than max, then max can be score, and we need to close these curly braces, and max should just be the right thing. Print line part 2 and max. Right, so scenic score, we need to have that function. I'll put it up here. Function scenic score, and we're going to take a map, which is going to have a U8, and it's going to have a X of U size and Y of U size. And this will throw, I guess, because the throws was because it was like getting stuff out. And this is going to return, I guess, an I-64. Right, so first off we need to get the viewing distance of each one. Yeah, so I guess we're going to have a ret, mute ret, and it can be 1, because we're going to be multiplying to this ret, and we need to get the, we'll also have a we'll have a num, I guess, and it will just be 0, and each time we'll set it away. And so I guess, yeah, all the ones on the edge will just have a 0 for that. So we want these similar loops, I guess. So looping over all the x's, we really want, yeah. So I think I will mute x equals x minus 1 and mute y equals y minus 1. Well, actually it can just be y for now. And while x is greater than equal to 0, we're going to do that. So just because we can't have the like for loops going in the opposite direction, we potentially can, I just don't know the syntax, so I'll just do it this way. And x minus minus. Cool, so when we do this, we're stepping each one back, and as soon as we as soon as we get one, well, we will num plus plus straight away because we've seen the tree, because we are in this loop. And if I suppose we should get a let size, actually I'll put that let size equal map, and that's just going to be y and x. Right, so if our size is so looking up, if our size is greater than or equal to whatever that is, then we will break, because that is where we are. And at which point we can probably go ret minus times equal num, and then num can be set back to 0, and x can be x plus 1, I guess, and this loop will be while x is less than, not less than equal, but less than, and that'll be map y dot size, because it is a array. And here x plus plus, and at the start we will see one, and if size is greater than equal to map of y and x, then we will break. And at the end we will ret times equal num, and we'll set num back to 0, and at this point we'll set x to x and y to y minus 1, and then I think we can just kind of copy these loops. It's quite verbose having like quite large loops like that. Heard some noises. Right, so now we want to do a loop on y, not g. That's the other side of the keyboard. And this can be y and y and y, and that can just be, we need a map dot size. And gosh, that can be that. Right, and at this point we probably can just return ret. Yeah, I think that will probably be good. Seeing its score is that. So what I might do is just run it and see what happens, and I'm hopeful that the example will now pass, because it will find 8 is our max, and we get a crash. Yeah, crash. Right, so we get an underflow of other loops. Build day 8 we get part 1, and then we get an underflow. So 0 minus 1, that means that we're in this function. Right, that should be that, but this means like, is it failing there? Yeah, it might just be failing there, which is a bit annoying because I guess we need to make this in i64 and this also be in i64, and we probably need to do something like this in as being i64 as being i64. And I'll see if that fails, because it will probably fail because it'll probably fail because, yeah, right, so it's done some stuff. I should just take a look. Yeah, so we need to just scatter through a bunch of stuff. So this can be as bang i64 plus 1, and this can be as bang i64 minus 1, and that can be as bang i64, and there should be one other y as bang i64. Right, so I think we'll still fail on yeah, that, because size returns a U size. And is that all it fails on? Yeah, it's happy with parsing the i64 to that. Alright, so I guess we can kind of assume, yeah, because y itself is U size, so adding 1 to it should be castable as U size. And we need it again for this as bang U size. Right, so that looks like it's compiling now. So whether it will give the right answer is something we'll find out. It's taking a long time to get that first build stage. I'm going to cancel it and just run it again. Gosh, yeah, it's slow. I don't know why. I wonder if instead of that we can do that, because it's potentially safer. As being i64. Unsure why that made a difference, but yeah, it did. Right, so we got 1 extra, so we reckoned it was 9, but it's actually 8. So I guess because we have the sample input, we can do some stuff. Right, so at the moment, group line view to left, yeah, this is left, is that, and we can just do num, and here we can, gosh, don't do that. Print line, a view to right is that, and down here, print line, view to north is none, and here, print line, view to south is none, and print line, score is red. Right. So we can do that, and we can look for the one where we have a 9, I guess, and work out why there is a 9. I don't know. Yeah, so I get a I. Gosh. I'll just do test 8 example. I only want the example, thanks. Alright, so we want to. The score seems to be 0. Score is 9 here. So I guess we. That's 5-1. Where am I there? No, I'm there. And we can just pass in that x and y. Right, recompile that, and yeah, 9. We're looking for that 9 case because it shouldn't be 9. Right, so we have 0, 0, 0, 1, 1, 9. So this 9 is at 3, 1. So that's x and y. So x is this way, 0, 1, 2, 3, and 1. So we're looking at this 1, I guess. And view to left is 3. It shouldn't be. It should just be 1 because that tree blocks us. View to the right is 1. That looks good. View to the north is 1. View to the south is 3, and it shouldn't because it is that. So I think what that shows me, in fact, yeah, so if we're 2, 1, because I think 2, 1, yeah, 2, 1 was this, view to the left is 2, 1 is that. View to the left is 1, which is good. View to the right is 2. It shouldn't be. Yeah, so it's stopping the wrong way. So I think what we need to do is, if our size is smaller than or equal to the map size, so that and that and that, and it was 4, yep. Right, so now we might pass, I guess, and if we do, I'll just delete the print output, and then yeah, so we don't have the diff of saying part 2, so we can just delete all these print lines. Where we have more there, and here, and here, and that is that. So if we do that again, and pass, so we can probably do the make run and do it again. It just sometimes does that. And then part 2 answer is probably this 535680. Hopefully. And it was right. So that means we can copy this, and I just realised I didn't make a commit for part 1, I guess. Day 8 dot output, but that's all right. So now if we could probably do that. So our test should just pass everything. Sometimes doesn't because of that like error rep 1. If we run it again, it's probably fine. It's interesting so if I time this, it gives that sort of time. Gosh, 6 seconds. But if I go into bash and then go into advent of code and then run the test.sh, it will give this output that it's the real user sys, because that's the built-in to bash. Because I was seeing this and I was like, where's that coming from? So now we get this. Interesting, it runs quite a lot quicker. Like there was only 2 seconds rather than 5, or like a bit over 1. Interesting. Anyway, so day 2. So if we go back to our advent calendar and yeah, we get that, and weirdly it's got some colour up on the 9. I'm not sure why. Gosh, yeah, that reckons like 14 seconds. I'm not sure. I don't know. But anyway, we can look up what we've done. So we've done both part 1 and part 2 in the same thing, which, yeah, it's just how that cookie crumbled, I guess. Commit day 9. Give me a sign. Day 9, day 8. Parts 1 and 2. And save that and go back here, get pull rebase, because it would have updated my readme. And I might add that make file, get add make file, and get commit. Would have been added with my get dot. So I guess what I want to do is just one, yeah, that one. Also added a make file so that we can run within Hack Studio on SerenityOS. We'll just do that. Yep, and now we can push, and that's that. Cool, I'm happy. And so now if we do that run, it will run through all of them. Interestingly, like, yeah, I'm not too sure what happened there. Yeah, cool. That is all that, and I think I'll leave that there and see you next time for another problem. And that did error, but it just had that stupid ret 1. I should try and debug that when it happens and like quit out. Yeah, I'll leave that for another one. And yeah, try and work out why it sometimes fails and sometimes doesn't. But for now, see ya, and I'll see you next time for the next problem.